Points A and B lie on circle O. The radius of circle O is 6 feet and the measure of angle AOB is equal to 120 degrees. What is the area of the segment enclosed by arc AB and segment AB? So again, it's just wanting to know this portion right here that we are finding. So again, we have our formula, and I am actually looking at these right here, and I'm noticing that they have 12 pi minus 9 square roots of 3 feet. So this pi here in the front and the 9 square roots of 3 feet squared is an exact form. So we'll be working this all out without a calculator because this is what's called exact form. It's not a decimal approximation. So this question is just wanting to know if you know your algebra skills with dealing with this. So again, 120 degrees goes in for theta, and I just had this, since we're in degrees, I kept this formula up from the previous question, and I found it from right here, this red box right there. So again, theta is 120 degrees, so wherever we see 120 degrees, theta, we're going to type in 120 degrees. Wherever we see r, which stands for the radius, we're going to type in 6 feet. And that was squared, so I want to make sure that that's correct. So then, all right. Well, I'm going to just first work on this first half, and then we'll deal with this half afterwards. So, 120 can be broken down as 120 can be broken down as 12 times 10, and 360 can be broken down as 36 times 10. So 10 divided by 10 reduces down to a 1. So 1 times 12 is just 12, and 36 times 1 is just 36. So then I'm going to just keep it here. So then we're looking at 12 divided by 36. Well, I know that 12 could be rewritten as 6 times 2. And I know 36 could be rewritten as 6 times 6. Or actually, I know that 12 could be rewritten as 12 times 1. Or 1 times 12. And I know 36 could be rewritten as 3 times 12. So again, 12 divided by 12 reduces down to a 1. So then that just leaves us with 1 times 1, which is 1. And 1 time, right here in the denominator, 3 times 1 is just 3. So that is what it leaves us with. So now 1/3, we can't break it down any further. So then I know that 6 squared is 6 times 6, which is 36. So now I have 1/3 times pi times 36, and again numerator times numerator. So these pi and 36 can both be written as a fraction over 1. So then we would have, I'm just going to combine them up here. So 1 times pi, I'm just going to copy these. Okay, 1 times pi 36, because it's numerator to numerator, and 3 times 1 is just 3 times 1. So that's how we would combine those ones. So now 1 times pi 36, well, 1, that would just leave us with pi 36, and 3 times 1 is 3. I know that 36 could be rewritten as 3 times 12. Then notice here that I have a form of 1 because 3 divided by 3 creates that form of 1. So then we would be left with a 1 right there, and pi 12ths divided by 1 is just pi 12ths, or 12 pi, because we can rearrange the order of it. So that's how we get to 12 pi. So that automatically just gives us this one. Now if you want to know how they simplified this, 6 squared again is 36. 1/2 times 36 gives us 18. And then sine of 120, this is where you would type in unit circle and pull that up. So again, in the unit circle, this will come, this is from Geometry A. The x coordinates are cosine of that angle, and the y coordinates are sine of that angle. So right here, square root of 3/2 is the cosine of 30, and sine of 30 degrees is 1/2. So again, sine is the y coordinate. So I'm going to look for 120 degrees, which is right here. And I'm going to look for the y coordinate because that's what sine of 120 is, which is the square root of 3/2. So if I came over here, I could use substitution and do the square root of 3/2. And again, when you're multiplying fractions, it would be straight across. So 18 times the square root of 3 would give us 18 times the square root of 3, and 18 is over 1, so then 1 times 2 is just 2, so that denominator did not change. So then we have, I can rewrite 18 as 2 times 9. Again, 2 divided by 2 creates that form of 1, so then I'm left with 9 square roots of 3. So that does confirm our answer.